Hello everyone, my name is Srin Gopal Krishnan from CKF, and today I'll be going over USACO 2020 February Contest Bronze Problem 2 Mad Scientist. First, let's start over by reading the question. Farmer John's cousin, Ben, happens to be a mad scientist. Normally, this creates a bit of friction at family gatherings, but it can occasionally be helpful, especially with Farmer John finding himself facing unique and unusual problems with his cows. Farmer John is currently facing a unique and unusual problem with his cows. He recently ordered N cows, and is between 1 and 1,000, consisting of different breeds, Holsteins and Guernseys. He specified the cows in his order in terms of a string of N characters, each either H for Holstein or G for Guernsey. Unfortunately, when the cows arrived at his farm, he lined them up, the breedings formed a different string from this original string. Let us call these two strings A and B, where A is a string of breed identifiers Farmer John originally wanted, and B is a string he sees when his cows arrive. Rather than simply checking if rearranging the cows in B is sufficient to obtain A, Farmer John asked his cousin Ben to help him solve the problem with scientific ingenuity. After several months of work, Ben creates a remarkable machine, the multi-cow breeder Flippinator 3000. This is capable of taking any substring of cows and toggling their breeds. All H's become G's and all G's becomes H's in the string. Farmer John wants to figure out the minimum number of times he needs to apply this machine to transform his current ordering B into his original desired ordering A. Sadly, Ben's mad scientist skills does not extend beyond creating ingenious devices. So you need help Farmer John solve this computational conundrum. Here's an input format. Our first line will contain N, which will be the number of cows that he originally wanted. The next two lines will contain strings A and B. String A will be the first line we receive here. This will be the original cow that Farmer John wants. String B will be the cow that he receives. Each string has N characters at either H or G. Output format. Print the number of times the machine needs to be applied to transform B into A. For example, first he wants 7 cows, and these are the original strings that he wanted, but he received this instead. As you can see, instead of getting a G, he got an H here, and instead of getting 2 H's here, he got 2 G's. First, FJ can transform the substring that corresponds to the first character alone, transforming B into GHGGHH, meaning he transformed the first H into a G. Next, he can transform a substring consisting of 3 and 4 characters, giving A, meaning the third and fourth ones he converted from 2 G's into 2 H's. He was able to do this because the 2 G's were consecutive. Of course, there are other combinations of 2 applications of the machine that also works. Now, technically, one way you could solve this problem is looping through each of these substrings and checking if they're equal. If they're equal, we can say check if it's consecutive or not by having a Boolean statement. If it's not consecutive, we will change the Boolean statement into true or false. Now let's see how I did this problem. First, I imported all these statements, all the files required to read the breed flipped file. Second, I set up the buffer reader first to read the file and print writer too so we could read the file. First, I took an N, then I took the 2 strings, and I set flip count. Flip count will represent the amount of times we have to flip the cows, and in block will be used to see if the strings are consecutive. And I set it equal to false first because in the beginning it won't be consecutive, unless if we find it consecutive, we'll switch it to true. We loop through each values of N, which is the amount of cows. We check the first char in the beginning and compare it to the second, string A and string B. We compare these chars of both and check if they're equal or not. If they're not equal, meaning that we have to switch the values, and if the things are not consecutive, we increase the count and set in block equals to true. So next time, we won't do flip count, even if they're consecutive. And the else statement represents that if we don't find if they're equal, that means it's not consecutive anymore. So we set it back equal to false again. And finally, we'll print out flip count, the amount of times we have to flip. And that's it for today's video. Please check out our backlog to check previous codes, and I'll see you in the next one. Thank you.